Our topic today is equations with brackets. So we've done expanding before. Now we're going to take that process into the equation process. So let me give you an example. If we had a room and we knew that it was 4 here and 2 here and x here. We've talked about these sorts of ideas before. We can express this as the length is 2 plus x. And the height there is 4, and so we multiply 4 times the length, 2 plus x. Okay, and we can expand that if we want to. Now, if we were to add another element to this and tell you that we knew that the total area was 12, then what could we do? We could say 4 times 2, we can expand that to 8, plus 4 times x is 4x. Is equal to 12. Okay, and then we can solve it from there. We move the 8 to the other side, subtract 8 from both sides. We're left with 4x equals 4. We divide by 4. And we get x equals 1. Clearly my picture's not drawn to scale, but you get the idea. So this is exactly the same as the expanding that we've done before, except now we're telling you what it's equal to, and so we can actually solve for x. Now, that is the distributive law, multiplying that into both elements inside. Okay? And as we progress, you'll also need to remember that we can only do this, we can only combine like terms. I think you'll remember how that works. Let's use a fairly simple example. 3p plus 4 equals 18. First thing we're going to do is we're going to expand the left-hand side of the equation. This is the left-hand side. So we'll multiply here, times gives us 3p, and we'll multiply here, gives me 12. And then we can solve it systematically, just like the ones we've been doing recently. We subtract 12 from both sides. This is adding 12, so we're going to subtract that so that the equation stays balanced. Always do the same thing to both sides. We take the 12 away, we're left with 3p equals 18 minus 12 is 6. This is multiplied 3 times p. To undo that, we do the opposite, which is divide. So we're going to divide by that same 3. Divide by 3. 3p divided by 3 is just p. 6 divided by 3 is 2. And I have my answer, p equals 2. You can always put that back in at the top to make sure. Check. Put in 2. 2 plus 4 is 6 times 3, 18. We've done it right. Okay? Now, we're going to use one. We're going to do another one here that is just a slight step harder. Not very much. We'll use minus 12. 3p plus 5 equals negative 132. Again, we're going to distribute in first. Distribute, we times, multiply, we get negative 12 times 3 is negative 36p plus negative 12 times 5 gives me negative 60, which equals minus a negative 132. We have a negative 60 here, or a minus 60 if you prefer. So in order to get rid of that, we're going to add 60 to both sides. Remember that we clear addition and subtraction first, trying to get the p by itself, trying to isolate p. So this goes away, this cancels, we're left with minus 36p is equal to, then we add 60 to that, which gives me minus 72. Then we have negative 36 times p. To reverse that, we're going to divide. We could divide just by 36, but it's a negative 36, so we'll divide by negative 36. Gets rid of the entire number over here. Divided by negative 36 leaves me with p is equal to minus 72 divided by minus 36. Negative divided by negative gives me a positive. 2 36s and 72, so my answer is p is equal to 2. Again, I can put it back in. 3 times p is 6, plus 5 is 11, times negative 12 gives me negative 132. One more example. This one will add an extra little element to this that we haven't talked about explicitly in this lesson. 4 times 2x minus 5 plus 3x is equal to 57. Now remember, when we distribute, the 4 applies to what's in the brackets. It does not apply to the 3x. It's multiplied by these things. So we'll distribute in times 4 times 2 gives me 8x. 4 times minus 5 makes it minus 20. Plus 3x equals 57. Before we go on, we're going to add like terms together. Remember, like terms are the same pronumeral raised to the same power. We can't put these two together because they're not the same pronumeral, but we can put these two together. 8 and 3 is 11. X, take away 20, is equal to 57. What will we do first? And remember that we undo addition and subtraction first. This is a minus 20. To undo it, we add 20. So we're going to say plus 20, plus 20. These two cancel. I'm left with 11x is equal to 57 plus 20, which is 77. 11 times x, undo multiplication by dividing. So we're going to divide by 11. Just going to leave me x here. We'll divide by 11 on this side. 77 divided by 11 gives me 7. Again, you can put it back in. 2 times x, that's 7. 2 times 7 is 14. Take away 5 gives me 9. Times 4 is 36. And then over here we have 3 times 7, 21. 21 and 36 is 57. So we've done the problem right. One more example. It doesn't matter when we're doing this process if we have pronumerals on both sides of the equation. Remember that our goal is ultimately to get the pronumeral on one side isolated by itself and everything else on the other side. So we're going to start with 2 times the quantity 3k plus 11 is equal to 5 times the quantity 2k minus 6. So we're going to, since we have pronumerals on both sides, we're going to start by expanding both sides. Here we have 2 times 3k gives me 6k plus 2 times 11 gives me 22 is equal to, then we'll expand this side. 2 times 5k, 10k, take away 5 times 6 is 30. Now remember, we want to get all the pronumerals on one side. Doesn't matter which side. Could be on the right-hand side, could be on the left-hand side. Since there's more k's over here, I'm going to, excuse me, this should be a k, not an x. Since there are more k's over here than over here, I'm going to move these to that side. So we're going to subtract 6 k's from both sides. These go away. 22 is equal to 10k take away 6k. Leaves me with 4k minus 30. So I've got the k's all on that side. I want the numbers all on this side. So this is a minus 30, so to reverse that I'm going to add 30 to both sides. I add 30 to the left-hand side, that makes 52 is equal to 4k. Because minus 30 plus 30, 0, that's gone. Last step, 52, 4k. I want k by itself. 4 times k, reversing that would be dividing by 4. Divided by 4 gives me k. Dividing by 4 over here, 52 divided by 4, 13. We have k equals 13, or 13 equals k. Again, we could put 13 in for k here, and for k here, and we would find that both sides balance. And that is doing equations with brackets.